All right, so this next video, looking in this section, is now thinking about measuring angles in a different way. So if we think about what we just did in placing angles, a lot of this has to do with distances moving around a circle. Right, we're thinking about moving in a circle as one rotation, that's 360 degrees. And really all of these angle measures just are based off of how much of that full circle we made. Do we make only half of that circle when we turn around? Do we do a full circle and then turn around a little more? So all of that stuff is based on just how much of a circle we're moving around on. Degrees are one unit to measure angles, and we say that 360 degrees makes up a circle. Now the number 360 is a totally arbitrary number. The reason we picked 360 was that it's a number that divides into a lot of things. Right, 360 divides by 2, it divides by 4, it divides by 3, by 12, by 6. There's a lot of numbers that can go into 360. And that made it convenient for us, rather than picking, like we could have just said 50 degrees makes a circle, and then base everything off of that, but then half a circle, fine, that would be 25 degrees, but then once we get to a quarter circle, that would be 12.5, you get a bunch of decimals. But with 360, we can say half a circle is 180 degrees, a quarter circle is 90 degrees, 1/8 of a circle is 45 degrees, and we can keep subdividing it a lot more than we can with some other numbers. So that's why we picked 360. But it's a totally arbitrary number that we just picked that was convenient. So instead of doing it with degrees, we also have a different unit called radians. And so the definition of radians is kind of weird to read, but I'll read it out and then we'll go over like what that actually means. So radian is the measure of the angle in standard position inside a circle whose terminal side intercepts an arc with the length of the radius. That's a lot of vocabulary and a lot of words that might not be the easiest to understand. So let's look at this picture and think about what that's saying. So if you have a circle, right, because all of these angles are based on moving in a circle. So we have a circle, and a circle has a radius. So that's the distance from this origin, the center of the circle, up to the edge of the circle. If I took that piece and I moved it onto the circle and then tried to fit it onto this edge, so the same length, but try to make it curved rather than straight, so the same length of this, but put on this side. So now I get a bit of the circle that's the same length as the radius. The angle that's made with that is called 1 radian. It's still a really weird thing to think about. We'll come back to that definition in a little bit, but we'll think about a different way to think about this. To think about radians a little easier than trying to deal with that definition. So we know that in a whole circle, so 360 degrees makes a whole circle. Makes a whole circle. And to make a whole circle in radians, we say that it takes 2 pi radians. Makes a whole circle. So 2 pi, that's about 6.28, right? Because pi is about 3.14, so 2 times pi is 6.28. So in this system, 6.28, that's the full circle. Rather than 360 degrees, we have 2 pi radians. So let's think about these radians in the circle. So starting at standard position, we'll do it on this big circle because it has some angles marked out for us. If I don't move at all, that's 0 degrees. It's also 0 radians. If I go all the way around, that would be 360 degrees. And that's 2 pi radians. So now let's think about what the other radian measures would be. So for a full circle, it takes 2 pi radians. So for half a circle, it should take half of 2 pi, which would just be 2 pi divided by 2, right? Half of 2 pi. And so half a circle, 180 degrees, is pi radians. A quarter circle would be 1/2 of half a circle, so pi over 2 radians. And then 3/4 of the circle would be 3/4 times 2 pi. And that would be 3 pi over 2 radians. So we get these equivalencies. 90 degrees is the same as pi over 2. 180 degrees is the same as pi radians. 360 degrees is 2 pi radians. 270 degrees is 3 pi over 2 radians. And we can keep cutting up the circle more. So if I go halfway from 90, I get to 45. Well, half of pi over 2 would be pi over 4. So 45 degrees, that's the same as pi over 4 radians. And then I can think about, well, 45 is pi over 4. To get to 90, I need 2 of those, so that's 2 pi over 4. And then to go to 135, that's 3 of them. So that would be 3 pi over 4 radians. Then I need 4 of them to get to 180. 5 of them go up to 225. 6 of them make it to 270. 7 of them go to 315. And then 8 of them will make the full circle. So we can kind of just dividing up the circle into fractions, where we know the whole circle is 2 pi. And so if we cut it into half, into quarter, into 1/4, into 1/8, 1/16, we get all these other angle measures. I'm going to fill out the rest of the circle so you know what those measurements are. But then I'll show you a conversion thing that you can use for this. So 30 degrees, that's pi over 6 radians. And 60 degrees is pi over 3 radians. Notice the angles we picked are those special angles in a triangle. 30, 45, and 60, those were those special angles I talked about. They're still going to be special. These are the angles we use as our anchor points for all of this. Using this stuff, we can make all the other angles that we need. For 120 degrees, that's 2 pi over 3 radians. This would be 5 pi over 6 radians. This is 7 pi over 6 radians. This is 4 pi over 3 radians. This is 5 pi over 3 radians. And this is 11 pi over 6 radians. So we get all of these radian measures. Eventually, as in like when you get to pre-calculus, you would be memorizing all of these angles. Like you would know intuitively. Just like you probably do this now with degrees, right? Like if I told you 45 degrees, you could probably visualize that in your head. Or like at least like 90 degrees, you could probably picture that in your head. 180 degrees, you can probably picture in your head. What we want you to get to by next year in pre-calculus or applied math is if I said pi over 2 radians, that should give you the same picture in your head as 90 degrees. Or if I said pi radians, that should be the same in your mind as 180 degrees is. Radians are a lot more useful to use in math and to do a lot of applications with for like the things that math was made to do. Mostly because radians comes out of this circle idea rather than degrees just coming out of this number that we picked to make it work out. And because radians come from that like innate idea of a circle moving around a circle, it gets used a lot more. And so we want to make this shift into thinking about radians rather than degrees. But it's the same thing. It's the same angle. It's just a different way of measuring it. It's just like how you measure lengths in inches, miles, feet, right? You have a lot of different units for it. It's the same thing. With angles, we have different units for it. We have degrees and we have radians. And in this case, we want to start using radians more. This is just your introduction to it. You just want to, the goal here is to just get you comfortable with this idea of a new unit used to describe angles. And start getting to visualizing angles with this instead. So a conversion that we can do is we know that 2 pi radians is 360 degrees, or pi radians is 180 degrees. And typically, so I'm writing RAD next to radians every time. Typically, you don't write units with radians. Radians don't have a unit. So I'm just writing it in to be really clear that I mean radians. But if you see it written out in a textbook, and when you write it, radians don't have a unit. Degrees have the degree symbol on top. Radians don't have anything. So let's see how we can use this conversion factor. So this means that for every pi radians, that's 180 degrees. Right? That makes sense based on our circle. We said 360 degrees is 2 pi radians, so a full circle. 360 degrees is 2 pi, which means half a circle, which is 180 degrees, is also just pi radians. So if we try to convert things, so we have some degrees we're going to convert into radians, and then radians we're going to convert into degrees. So 135 degrees. Let's also practice just seeing where these angles are. So 135 degrees, if I start off facing the positive x-axis, 135 is going to be, well, I'll have to do 90 degrees and then a little bit more. And it's going to be somewhere there. So that's my angle. To convert, I know it's 135 degrees. I'm going to use dimensional analysis on this. But it's a very simple version of dimensional analysis because we're just doing one conversion. We're starting off with the units in degrees and we want it to get to radians, which means we're going to use this conversion factor where I multiply that factor, putting the degrees on the bottom so it'll cancel out, and the radians on the top. And then once I simplify this, I'm going to try reducing this fraction. I'm going to get 3 pi over 4. And that's my radian measure. Again, for radians, you don't have units for it, so you just write 3 pi over 4. And that's the same angle. Negative 40 degrees, I do the same thing. So you can think about where this angle is. So I'm starting off facing a positive x-axis. And now I need to move in the negative direction, so moving clockwise. And then negative 40, so that's not going to get me to the 90 degree mark, so that's somewhere over here. Just estimating to see where the angle is. Again, I multiply. Since I start off with degrees, I need to cancel it, so I put degrees on the bottom, radians on the top. The degrees can cancel. And I can simplify this down. I'll get negative 2 pi over 9 radians. Right, so if you want to look at how I'm simplifying this, I get 135 pi over 180 when I multiply this. But then 5 goes into both of these things, 27 times and 36 times. And then 9 goes into this 3 times, 9 goes into this 4 times. Over here, the zeros cancel. 2 goes into 4, 2 goes into 9, and you get negative 2 over 9. Now we're going the opposite direction. So now it's giving us radians, 5 pi over 4. So let me think about this again. I have my positive x-axis facing thing. I need to move 5 pi over 4. So if I look back at my circle, pi over 4, that was the 45 degree thing. So if I need to move 5 of them, I go 1, 2, 3, 4, 5. So that's going to be over there. And if I look back, 5 pi over 4, that was down at the bottom there. Right, so just the way I thought about this, I knew that pi over 4 was halfway to the 90 degree mark. So I moved 5 times that distance on the circle, and I got to this angle. So 5 pi over 4, I'm starting off at radians. So I put the radian on the bottom, and I put degrees on the top. The pi's will cancel. I can reduce to 4 and 80, 180. Right, that's 90. I can reduce it some more to 45. And I get 45 times 5, which is 225 degrees. Last one, 1 radian. So this one's slightly harder to visualize. So it might be easier to do this in degrees instead first. So 1 radian. So I have radians on the bottom, degrees on the top. going to be 180 over pi degrees. If you really want to get a decimal version for it, you can divide it, and that would be about 57.3 degrees. So that's somewhere over there. So that's the second video. That's the new unit of angles we're using. So instead of degrees, we're using radians. And we want to get comfortable with these radian measures. That's the main goal of this week.